Here is the answer for the round 33 day 4 bell work. Question A. Find the pH of a solution if the concentration of hydrogen ions is 8.7 times 10 to the negative 6 molar. And then we're asked, is that acidic, neutral, or basic? A solution is acidic if the pH is less than 7. It's neutral if the pH is equal to 7. And it's basic if the pH is greater than 7. So let's find the pH and then we can answer that question. Here is the formula for pH. pH is equal to the negative log of the hydrogen ion concentration. And we were given that value. So just substitute that in there. Take a calculator and push negative log, type that number in, and push enter. And it will say 5.1. Because that number is less than 7, the solution is acidic. Now question B. Find the pH of a solution if we know the concentration of hydroxide ions. And then the same thing, is it acidic, neutral, or basic? This time we're given the concentration of hydroxide ions, so it makes sense to find the pOH instead of finding the pH. And here's the formula for pOH. It's the negative logarithm of the concentration of hydroxide ions. That number was given to us, so substitute that in there and use the calculator. Push negative, then the log button, type in that value and push enter. Now it's going to say 2.6. That's the pOH. We were asked for pH. So there is a very straightforward equation that relates those two numbers. pH plus pOH always makes 14. If we know that pOH is 2.6, then we can find that the pH is 11.4. Because the pH is greater than 7, that is basic. Now question C. Find the concentration of hydrogen ions in a solution when we're given the pH value. So use the pH formula because that gives a relationship between pH and concentration of hydrogen ions. Now let's pull a couple of algebra tricks here to get the concentration of hydrogen ions alone. First, divide by -1 on both sides to get the logarithm alone. Now we have negative pH equals the logarithm of the hydrogen ion concentration. Now let's remove logarithm by doing the inverse operation of a common log. A common logarithm is base 10. So we're going to exponentiate both sides using base 10. To exponentiate, you use 10 as the base, and then this becomes an exponent on the 10, and this becomes an exponent on the 10. So on the left side of the equals, we have 10 raised to the negative pH power. On the right side, when you use base 10 and you raise it to an exponent that is the logarithm of something, you just get that argument of the logarithm, in this case, concentration of hydrogen ions. And so you can see here that we've taken an equation for pH and created from it an equation that has the concentration of hydrogen ions alone. It would be worthwhile just to memorize this or have this in your notes so that you don't have to go through the algebra steps to get it. The pH is 4.5, so you plug that number in up there in the exponent. So 10 to the negative 4.5 power on a calculator is 3.2 times 10 to the negative 5th power. Because we're finding concentration, the label is molarity.